Alright, so today we'll be going over implicit differentiation, and that is whenever you have a function that's not in terms. It can't be. For this next question, we have 4x squared is equal to x cubed times y plus 3x squared times y cubed. And now we want to differentiate both sides. What that means is we're going to, and we want this with respect to x. It's going to be 8x equals, we're going to have to use the product rule here. So we're going to put this in parentheses. And let's start simple. The derivative of the first function, 3x squared, and then original function, y. And then now we're going to have to add that with the derivative of the second function, which is going to be 1 times dy dx. So dy dx and then times the original, the second function. So this is going to become x cubed. Quick adjustment, this should be a 3xy, not just a regular y. Next, we have the problem 3x squared minus x squared y squared equals 4x cubed y cubed. So differentiate both sides with respect to x. And since I left myself a little more space, I might as well write it this time. So that's the derivative sign. So here we have derivative with respect to x. And differentiating both sides. Now we get this with respect to x. So this becomes 6x using the power rule minus, and now we have a product rule here. So what we want to do is simply x squared y squared. So we'll go derivative of the first times the second. So 2x y squared plus original of the first derivative of the second, which is going to be 2y. But then y as a function of x, that has its own derivative, so now we have to multiply that by dy dx. And now this is going to be equal to the derivative of this side, and we're again going to have to use the product rule. So let's factor out the 4 for simplicity's sake. First derivative is going to be 3x squared, original of the second function, y cubed, plus the original function x cubed times the derivative of the second 3y squared times dy dx. And now we have our equation that we have to simplify. And what we can do, let's distribute this negative, and we'll distribute the 4 so you see what you have to work with. 6x minus 2x y squared plus 2 x squared dy dx equals 12x squared y cubed. Oh, and minus on both parts. Got that. 12x squared y cubed plus this 3 again, 12x cubed y squared dy dx. And now we want to spot the terms that have a dy dx, this and this. So we're going to move it to one side, and since it's easier, we'll just move this one over here so it becomes positive, and we'll just subtract this, and yeah, we can keep working from there. So now we got 6x minus 2xy squared minus 12x squared y cubed equals 12x cubed y squared dy dx plus 2y x squared dy dx. And now what we can do, factor out the dy dx, and we leave this side the same. Actually, we can factor out an x, so this becomes x times 6 minus 2y squared minus x minus 12xy, so minus 12xy cubed. And I also realized I can factor out a 2. We'll do that in the next step. And this becomes dy dx times what's left, 12x cubed y squared plus 2y x squared. And this does have a common factor of x squared y, so we will end up factoring that out too. So now onto this side, we're going to end up dividing this, right? So we have not 2y, rather 2x times 3 minus y squared minus 6y cubed. And then this is all going to be divided by here. Before we even divide, we can notice we can factor out a 2yx squared. So what this becomes is 2yx squared times, and then this function in here, 12x cubed y squared, this is going to become 6. We drop down this by 2, so 6x y squared minus 1, so it's going to be 6xy, and then we factor out this whole expression, so this is just going to be 1. And now, 2's cross off, x's cross off, of course this is still equal to dy dx. Now, for our final step, we can write dy dx is equal to 3 minus y squared minus 6y cubed all over y times 6xy plus 1. And this is our final answer. I apologize once again. This should be an xy cubed. This should be an xy right here. Alright, same process. So we'll find the derivative. We're of course differentiating 5xy cubed equals x minus 3x cubed y squared. I'm just going to draw a big bracket around the whole equation. This now we have a quadratic rule, so factor out the 5, we got 5, and we'll just go derivative of the first function here, x, derivative of that is 1 times y cubed, of course that should be y cubed, and then y cubed plus derivative of original function times derivative of the second one, that's of course 3y squared, and then we don't forget multiply by the derivative of y with respect to x, and then here derivative with respect to x of x, that's 1 minus, and then the 3 out there, constant multiple, factor that out, and this becomes derivative of the first function, 3x squared, original function, y squared, plus original first function, x cubed, times derivative of the second function, 2y, and then dy dx with the chain. And now what we want to do is 5y cubed plus And we're gonna distribute, so 5y cubed plus 5 times 3 is 15. 15 x y squared dy dx, and this is now equal to 1 minus 3 times 3, this is 9, so 9x squared y squared, and then plus 3 times 2 is 6, plus 6x cubed y dy dx. And now we see our dy dx term here. What we want to do, we can subtract that to we're gonna subtract that to this side, subtract that, the other non-dy dx term, to that side, and now what we're gonna have is 15x y squared dy dx minus 6x cubed y dy dx dy dx, and that's equal to 6x cubed y dx. This is going to be 1 minus 9x squared y squared minus 5y cubed. Factor out the dy dx. What we get, dy dx times, and this is going to be, and we'll remember we can factor out a 3xy on the denominator, so that's what we'll do. And this becomes 15x y squared minus 6x cubed y, and this is equal to 1 minus 9x squared y squared minus 5y cubed y squared minus 5y cubed, and of course divide both sides. So now what we get is dy dx is equal to 1 minus 9x squared y squared, let's not forget that part, minus 5y cubed all over 3x y times 5y minus 2x squared. And that is the final answer. Now for this one, again, we just define the derivative with respect to x of the whole equation. Alright, let's start with x squared. Derivative of this is just going to be 2x. And derivative of 1, that's 0. So we can just write that down. Now this is going to equal, since we have this, we can use a chain rule. No more product rule for now. So then we have 2 times y cubed plus 2x cubed. That's what's inside. But then we have to multiply it by the derivative of the inside. So we're going to put it in another parentheses. Derivative of this, that's going to become 3y squared. But then we have to multiply it by dy dx. So times dy dx. And now derivative of this is just going to become 9x squared. So that's what we have here. And now, it honestly could have gone better if we did just square it out, but it is what it is. Let's keep working through it. Now, what we have is, we can divide these 2's on both sides. So I'll leave it factored out. So now, 2 times, we're going to distribute. So this becomes 3y to the 5th, because y cubed plus y squared. Y cubed times y squared plus y cubed times 9x squared becomes 9x squared y cubed, and then plus 9 x cubed y squared. And then this becomes 3 times 9 plus 27 plus 27 x to the 5th. And now, divided, we just cancel out the 2's on both sides. This leaves us with x equals 3y to the 5th plus, and I don't know how I did that, but it's 3y to the 5th dy dx. This is still here. 3y to the 5th dy dx. That's a y, you gotta trust me. And now we have, and I did it again here. This 9x cubed y squared also has a dy dx. I'm a little tired, but that's fine. Now, working through this, 3i to the 5th dy dx plus 9x squared y cubed plus 9x cubed y squared dy dx plus 27x to the 5th. And parentheses here. And now what we have, this is our dy dx term, this is our dy dx term. Subtract this over, subtract this over. So now what we have is x minus 9x squared y cubed minus 27x to the 5th is equal to 3y to the 5th dy dx plus 9x cubed y squared dy dx. Factor out the dy dx, and we can factor out an x over here while we're at it, which becomes 1 minus 9x y squared minus 27x to the 4th, and this is equal to 3y to the 5th. So this is going to be dy dx times 3y to the 5th plus 9x cubed y squared, and we will be able to factor out a 3y squared. Now, dividing and moving to the other side, we have dy dx is equal to x times 1 minus 9x y squared minus 27x to the 4th all over 3y squared times y cubed plus 3x cubed. And that is question 5. So, with this problem, there are 2 approaches that you could take. You can either square this out and then you have to work with the product rule, or you could not square this out and just only deal with the chain rule, then some binomial multiplication. Last time we did the binomial multiplication. This time we will be dealing with the product rule, so we'll square this out. So, before we can take the derivative, you have to actually square this binomial. This becomes 16y to the 4th plus 2 times 4y squared times 2x is going to become 16y squared x, and then this is going to be plus 4x squared, that's 2x whole squared. Derivative, differentiate with respect to x of the whole equation. This now becomes 3x squared equals 64y cubed dy dx plus 16 times, now it's product rule, derivative of the first one, 2y dy dx times the original of the second, x, and then plus 2, we're going to have y squared times the derivative of the second, that's just 1, so we don't need do anything. And now this is also going to be plus this one's derivative, which is just 8x. Now, what we want to notice is we want to distribute everything, right? So let's bring that down to a lower step. 64y cubed dy dx plus 32y x dy dx, and then plus 16y squared, and then plus 8x. Now, what we can do, notice this and this are our dy dx terms, so we're going to leave those here. We're going to bring these two terms over to this side. This becomes 3x squared minus 16y squared minus 8x equals 64y cubed. And actually, what I'll do, actually no, that's fine. 64y cubed plus 32yx all times dy dx. And now we can divide both sides by this, and we can also factor out a 32y. We can't factor anything out on this side, which will be the numerator. So what we get actually is 3x squared minus 16y squared minus 8x all over 32y times 2y squared plus x. And double check. Yep, that all makes sense. And this is, of course, now equal to dy dx. And that is one of the approaches to question 6. Doing the other, of course, will get you the same answer. Now, I skipped to question 8 because question 7 was very repetitive. It's the same exact process. And question 8, it's literally the easiest type of question you can see here. All addition, no difference between y's and x, nothing multiplied together. Really easy. So let's just do it. So, differentiating this with respect to x, we got 9x squared, the other side, and then this 2y squared, this becomes 4y dy dx, and then 2x, this just becomes 2. This 4 now becomes a 0, and now that we have that, this is our dy dx term. We're going to keep it here. So now we have 4y dy dx equals, and then this is going to be negative 9x squared, not plus 2, but minus 2. Minus 2 divided by 4y, we get dy dx equals negative 9x squared minus 2 all over 4y. That is quite literally it for question 8. It's one of the easier ones you can encounter. Alright, what we have here is a circle problem, and it's asking us to find the points where dy dx is equal to 3/4. So first thing we want to do is differentiate this. Applying power rule 2x plus 2y, then the implicit differentiation times dy dx. This is equal to 0. Derivative of 25 is 0. So now what we want to do, move the x to the other side so we can begin escalating dy dx. This becomes negative 2x, and then 2y dx. What we get is dy dx is equal to negative, and these 2's are going to cancel out, so it becomes negative x over y. And that's the case for any circle. And now, what we need to do to find the points is we have to set up a system of equations. So what that means is that, well, of course, negative x over y has to be equal to 3/4. But this also has to be a point on the circle. So x squared plus y squared is equal to 25 as well. And now what we can do is solving for x. Let's go down here. We got x equals negative 3y over 4. So what that means we can do is we can plug this back into here. So you get negative 3y over 4 squared plus y squared equals 25. And now, just squaring this, we get 9y squared over 16 plus y squared equals 25 now, 400. Then we multiply by 16, which then gets us to 400. So 9y squared plus y squared plus 16y squared equals 400. This becomes 25y squared divided by 25. We get y squared equals 16 plus 400 divided by 25 is 16. Y equals plus or minus 4. And what that means is we can just plug it back into this equation and get our x coordinates. So negative x over, we'll go negative 4 for this one, is equal to 3/4. These negatives cancel, and when we multiply, these 4's are going to cancel, which means x equals 3 when y equals negative 4. And now we have negative x over positive 4 equals 3 over 4. These 4 are going to cancel, which means x is going to be equal to negative 3. Meaning our answer is going to be 3, negative 4, and negative 3, 4. And that is the answer to the last problem. Thank you for watching. If you have any questions on implicit differentiation, be sure to message me. And thanks for watching the video all the way.